channel. Now basically each episode I'm going to cover a physics topic and hopefully try and explain it in a simple and understandable way. Some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today I'm going to be chatting about Brownian motion, and it's quite a simple principle, so hopefully it should be a good episode. Before I get into the whole spiel about what Brownian motion is, first let's double check we understand how molecules in gases and liquids behave. Just a side note, both liquids and gases can be referred to as a fluid. So if you hear someone referring to a fluid, this could be either a gas or a liquid. Fluid. So let's start with gases. A gas consists of small molecules that are far away from each other and are arranged randomly. And so random, gas molecules can move quickly in all and any directions. As a result of these behaviours, a gas can fill any container it's in, and it can also be squashed. Whereas in a liquid, the molecules are closer together, but are still arranged randomly. So liquids will take the shape of whatever container they're in, but they will not fill the space like a gas. So let's take putting a gas and a liquid into a glass jar. So if you put a gas like deodorant into a glass jar and put the lid on it, the deodorant would spread out and completely fill the jar. But if you put water in the jar, it would not take up the entire volume of the jar unless you put the exact right volume of water in. Both gas and liquid molecules move in a similar way. They move in a straight line until they hit another molecule, and then they boing off in a completely new direction. Boing. And then they continue in that straight line until they hit another molecule, and so on. Because the particles in a liquid are closer together and are more condensed than they are in a gas, the liquid particles don't have to travel as far before they collide and change direction. So, to build on this, Brownian motion is defined as the random movement of particles in a fluid. And this random movement of particles in a fluid is caused by collisions with other molecules in the same medium, which is kind of a summary of what I've just been talking about. So, let me help you visualize. Say you're in a room that's like half full of other people. Everyone in the room has to walk in a straight line until they bump into someone else or the walls of the room, aka the container. When this happens, they have to change direction randomly and carry on walking in a straight line in their new direction. For a liquid, the room may be 75% full instead, so you'd have more people in the room and therefore more people to bump into, so less time between each encounter. Less time! This completely random way of molecules moving over time is what we call Brownian motion. If you were wearing a GPS tracking device and you tracked the steps you took for the exercise in that room, when you checked your tracker app later, the path that you walked would look completely random. Just like this. Some of the variables that will affect the rate of Brownian motion include increased temperature, because that makes the molecules travel quicker. Increasing the number of particles will increase the number of collisions occurring. And altering the size of the molecules will also affect Brownian motion rates. So there you have it. When you think of Brownian motion, think of that room where people refuse to move out of each other's way and bump into each other. Rude! Thank you for listening. If you like this video and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.